So this is titled Complex Fractions. The first thing that I want to point out is something very, very similar, very basic. If we have 3 over 4, some fraction, divided by 5 over 7. This is all that's different today. It's written like this. That's the only thing. This is the same as I almost put an extra S on that. Same as 3 over 4 divided by 5 over 7. And we already know how to deal with this. Or we should. So we don't get common denominators here because we're not adding or subtracting. The only time we get common denominators is if there's a plus or a minus in between here. So this, you leave the same except for you keep this one, you flip this one over, and you change this to multiplication. So 3 over 4 times 7 over 5. 7 over 5. And if nothing cross cancels, like here, you just multiply straight across the top. That would be 21 over 20. So really, it's no different than this. I'm just going to show you examples so that you can refresh your memory on how to deal with stuff like this.
So this is as hard as
It's
no.
the warm-up will be like as hard as it'll get. Maybe. We'll see. I'm going to do examples that are like all of the problems, so you'll have an example for each one, at least. I have 5 examples. The only thing I would do, because it'll feel like a lot less work because there's a lot less writing, I would look at this for my problem, and I would immediately jump to this step. I don't have to write this in between every single time. So from here, I would write this. That's, I think, the key. And I'll do that for the examples. So we're just going to simplify. This is for all the examples. Simplify. It's going to look nasty, but we'll write it out and then it'll look exactly like the warm-up. I guess just as a note on the side, if we have 3x with parentheses around it and it's raised to the third, do we remember what this is?
3x.
Yes. So the long way is writing 3x, 3x, 3x. 3 times 3 is 9, times 3 is 27. X times x times x is x cubed. So this is the same as 27x cubed. This looks way more intimidating than it will turn out to be, in my opinion. I'm going to put this in a little bubble. The whole reason I wrote this out was so we can deal with this part. And it should be pretty much okay. Remember, I'm going straight from this piece to this piece, the multiplication. It's 2y quantity squared, 5x squared, 4y cubed, 10x cubed. So the first thing I'm going to do is rewrite this. I'll take a lot of room to do this just to make it more clear. Again, I'm skipping to this step, so I'll write 4y cubed over 5x squared times, flip this one over. Actually, let me change this. What would this change to? 2y times 2y. Who said that? And then what would that be? 4y squared. So this changes to 2y times 2y, which is 4y squared. So instead of writing this, remember I need to flip this over. So actually I'll write the 10x cubed first. And then this changes to 4y squared. So on this one, The 4 and the 4, those cancel out to 1 over 1. Maybe I should do this. 1, 1. The 10 and the 5 would cancel out. What this would be divided by 5 is 2. This divided by 5 is 1. And just to make it not super messy, I'm going to write 1 times 2 is 2. And then x cubed, y cubed. I just like to write the x first. And then 1 times 1 is 1. X squared, y squared. Yeah.
So I did mine a bit differently. I cross multiplied the coefficients, and I got 40y cubed x cubed over 20y squared x squared.
And then you just reduce. That's fine too.
Does that still work?
Mm-hmm. So if you wanted to, yeah, you could just multiply the coefficients. That makes the numbers bigger, but it still works. You just have to reduce at the end. Here, we're already reduced because we reduced here. So it's just reducing in a different step. And then now we deal with our exponents. The x cubed is bigger. So I'll do 3 minus 2. That to x to the 1. 3 minus 2. Y to the 1. 1 on the bottom or just nothing.
It's negative 100.
72. Actually, I don't know what the temperature is in here, but the thermostat set to 72.
It does not feel like 72.
What do you want me to do? I'll change it. Okay, just give me a second. All of that is in the video now. The 3 plus x, that's the same thing as an x plus 3. You can switch it around because it has that plus there. Yeah, I'll give you time to work on that. On this, I will keep the top one. This is the same thing as an x plus 3, so just keep that in mind. And then the 18x, change this division bar to multiplication and flip this one over. 9 on top, 7, x plus 3, x minus 2 on the bottom. The x plus 3 and the 3 plus x cancel. The 9 and the 18 you can reduce. 18 divided by 9 is 2. 9 divided by 9 is 1. So in the top, we're left with just 1. And in the bottom, we're left with 2x and 7. And then x minus 2, I'll write this out in 2 steps just to make it extra clear. 2x times 7 times x minus 2. The 7 and the 2 are both coefficients, so we can multiply those. This is 1 over 14x, x minus 2. I didn't mean to have, this is not canceling out. It's just a streak. So y divided by y minus 8, all of that divided by y divided by 8 minus y. So keep this one, change this to multiplication, flip the second one. All right, so the trick is for this piece here. So I'm going to do this like as an aside. 8 minus y, you can factor out a negative 1. Whatever you divide by goes on the outside of the parentheses. And then that's negative 8 plus y, which, since there's a plus in the middle, you can switch them. So negative 1, minus 8. So if I rewrote the problem, it would be y over y minus 8 divided by y over y minus 8. You could actually, just from here, consider that you're having the same thing over itself. That right there is like, oh, it just cancels out to 1. Except for, I missed this part. This would be negative 1, right? Yeah, I missed that. So it's almost canceling out. So let's just do all the steps that we just had. Keep this one. Y divided by y minus 8. change this to multiplication, flip this over, negative 1, y minus 8 over y. The y's cancel to 1, the y minus 8 cancels to 1, and so we just have negative 1 as our answer.